Hello calculus friends, and welcome to another wonderful calculus video. We're going to expand upon the idea of that disk method a little bit more. You guys seem to be really handling the disk method well, so hopefully the washer method goes just as well. It is a little bit trickier, so if you're not one who likes to draw the pictures, I strongly urge you to actually start drawing these pictures to figure out the big radius and the little radius. It is actually very helpful to do so. So what's going on when we have this washer method sort of thing is that we're taking a rectangle still and we're spinning that rectangle, but notice what's going on over here in our little diagram. Our representative rectangle has all of this blank space between it and the axis of revolution. That's going to create a little hole when we spin it. So we have this little value here that was our blank space from up there. So notice this looks like a washer if you've ever seen, not the clothes washer, but a washer. And that's why this is called the washer method. So we just need to set up our integrals a little bit differently, using the big radius and now the little radius as well. So draw your pictures. As long as you can identify big radius, little radius, this is going to go just fine, but it is a little tricky at times. Okay, so down here they're talking about that volume of the washer being pi times the big radius squared minus the little radius squared times the width. And remember, when we do integrals, that width is going to 0 because our rectangles are getting super narrow. Okay. Here's kind of what happens when we take these super cool shapes and we spin them. We have one function and another function up here, and we have a large radius. It always goes from the outside of our solid or our shape to the axis of revolution. So to find big radius there. And then the inside radius or the little radius is always that closest function to the axis of revolution. That's how I think about finding those. When we spin that shape, we kind of get this awkward looking cone of shame thing that like dogs have after surgery or whatever. That's what the solid looks like. Three-dimensional solids are very hard for me to draw, so I rely on the pictures of other people to help visualize things. Here is our official washer method formula. Notice you'll see that big radius squared minus little radius squared, still integrating from a to b with a pi out front because we're still really doing circles. We just have a big circle and we're subtracting out that inside circle that is our hole. So let's do a couple. Okay, here we have the graph of y equals root x and the graph of y equals x squared, and it is important that you know which is which. So this function out here is our square root of x, and this function in here is x squared. It is labeled over there. You just need to graph them and make sure you know which one's on top and which one's on bottom. We're always going to take top minus bottom, or big R minus little r. So in this case, I always write them down. Our big radius goes from farthest away function to axis of revolution. We are rotating around that x-axis, so big radius right there. That is the distance all the way to square root of x, so our big radius is root x. Our little radius goes from closest function to axis of revolution, and our little radius in this case is going to be x squared. Okay, that means our volume of the solid that's rotated, it kind of looks like this. The outside looks like a bowl, but the inside has this strange little like curvy shape in it. Wouldn't hold much cereal. Pi integral from, we're looking at intersection points a to b, so we're using 0 and 1, and we want our big radius squared, so the square root of x squared minus the little radius squared with respect to x. So pi, integral from 0 to 1 of x minus x to the fourth. And oftentimes these are not too bad to integrate by hand, and I would encourage that you still do some from time to time by hand just to keep in practice with the correct notation, especially considering your AP test come May is going to be all handwritten or all typed out. You're going to have to rely on that notation. There will be no multiple choice questions to kind of help you out with that, just FRQs. So this is going to be x squared over 2. This will be x to the fifth over 5, evaluated from 0 to 1. So we're going to have 1/2 minus 1/5 minus 0, which doesn't matter. And common denominators. So 5/10 and 2/10. So 3 pi over 10, if I did my math correctly, would be our volume of this super cool shape over here. All right. We'll do one more before I let you work on the 4 homework problems for tonight. This one is taking some more 4 different equations and revolving them, or the boundary of 4 different equations, and revolving around our x-axis here. Sorry, y-axis, I can read. So big radius goes from farthest away all the way to the axis of revolution. So our large radius goes from this line, x equals 1, all the way to here. So that length is a solid 1 unit. That one does not vary. Our little radius goes from the inside function to the axis of revolution. So that is inside function. Okay, this is our closest to the y-axis, so there's our little r right there. That radius has to be in terms of y, so you can actually see that they solved that over there. For y, so we could get, or for x, so we could get it in terms of y. So square root of y minus 1. When we plug into our volume formula, pi times the integral, we're using our x coordinates, our y coordinates, to figure out this volume here. 0 to 2. Big radius squared minus the little radius squared. And of course, you can actually square these before you plug them in to have a little less to write down, but I'm showing as many steps as I can, hopefully to help you out. All right, and this one doesn't look too terrible to do on our own. We're going to have a minus y plus 1. So that's going to be actually the integral of 2 minus y, which looks easy to do. So let's do it. 2y minus 1/2 y squared from 0 to 2. And we will have 4 minus 2, I think. So this volume, or this solid, has a volume of 2 pi. I hope this helps you out. You have the 4 questions to work on for your homework tonight. All of them either go around the x-axis or the y-axis. Let me know if you have any questions. Have a good day.